also want to look at this and apply some algebra to it. So let's read the question. It says the sum of 10 terms of an AP. I've used the short form AP here to stand for arithmetic progression or arithmetic sequence or series is 60. So clearly you can identify that S10 is 60. I'm just going to summarize what the question says there is S10 is equal to 60. Okay, and the sum of the second and the sixth term is 9. So if that means that T2 and T6, when we add the two together, we get 9. Okay, so right now, and then it also asks us to find the sequence. Now, you have to unpack this question and see what it's really looking for. When it asks you to find the sequence, it means give us at least the first 3 terms of the sequence. Secondly, we've identified that it is an AP or arithmetic progression, right? It is an arithmetic progression. Let's just fix the handwriting there and try for an improvement. Right, it is an arithmetic progression. So once you know if it's an arithmetic progression, 2 things that define this: you need a starting term, number 1, and you need number 2, the difference. Because you can just take the starting term, add the difference, and then you get your next term, add the difference again, and then that's what you get, right? Okay, so let's see if we can solve this. S10 equals 60, T2 plus T6 equals 9. Okay, so I'm going to do that again over here. S10 is equal to 60, and also given is that T2 plus T6 is equal to 9. Right. So what does this mean? Well, essentially S10 is simply the sequence for the formula for a summation, which is going to be n over 2, and in this case n is 10, so it's 10 over 2 multiplied by 2 times a plus n minus 1, 10 is n, so n minus 1 has to be 9, multiplied by d, which is that. And you know that when you work this thing out, you've actually got a value of 60, right? So let's start there. That's our departure point. Secondly, you have T2 and T6. Now, T2 plus T6, I'm just going to put this over here. T2, sorry about that, plus T6. Let's substitute in what T2 is. T2, as you know, it's just the first term plus the difference. So T2 is going to be the following. It's going to be A plus D. That represents the T2 part. And the next part, plus T6, is going to be A plus 5D. And these are things that you should know by now from the arithmetic formulae. And we were given in the question that this thing over here is equivalent to 9, right? So at this point, let's simplify each of these two equations. If you simplify this one, you're simply going to get A plus another A, right? And that gives you 2A, right? And then you have D plus 5D, and that's going to give you 6D. So let's simplify that one over there. And then let us simplify the other one as well. So that's T6. Okay, this thing over here is fairly trivial. I'm just going to do that on another page to show you the simplified version. So you have your 10 over 2, which you should know by now is 5, into 2A plus 9D is equal to 60. Divide both sides by 5 to get rid of the 5. Right? So 60 divided by 5 is 12. And the 5 on this side cancels out. And I'm left with 2A plus 9D. Now, I want you to see something over here. Do you see that you have 2A? And in the other one, this thing over here simplifies into 2A plus 9D. So I'm just going to put the simplified version of this top one on the side. 2A plus 9D is equal to 12. And on the bottom one, remember A plus A is 2A. And 5D plus D gives me 6D. And 6D plus 2, oh my word, horrible mistake there. That was 2A plus 6D is equal to 9. Now I want you to notice is you can use what we call a substitution approach, but I think that that is unnecessary because we can see that we have 2a and we have 2a again. So if I call this thing equation 1, and I call this equation 2, and I say that I want to take this thing over here, I can take equation 1 minus equation 2, which just means you're going to take that minus that. Okay? And so let's subtract them. 2a minus 2a leaves me with no a's anymore. And then 9d minus times positive 6d, so it's 9d minus 6d gives me 3d. And 12 minus 9 gives me 3. Right? Therefore, I can now conclude that d is equal to 1. Okay, at this point in time you can just go back. It is simultaneous equations. You could have used the substitution method or the elimination method to solve this, right? Because the moment you have two equations with two unknowns, you can clearly see that it is solvable, right? The moment you have more unknowns than the number of equations, that's not possible to solve. However, we're not done. We still need to find a. So let's just back substitute that. I'm going to say it's 2 times a plus the 6 times the d that we just found now, which is 6 times 1, is equal to 9. And that leaves me with 2a is equal to 3. 2a is equal to 3. Am I right? Yeah? Okay, and therefore a is equal to 3 over 2. So my first term is 3 over 2. And if I want to find the sequence, the first term is 3 over 2. The next term is going to be 3 over 2 plus 1, which is going to be 5 over 2. Right? And then the next term is going to be 7 over 2. If that was a bit difficult to see, you could have done this part on the calculator. Alternatively, you can say 3 over 2 is 1.5. If you add 1 to that, you're going to get 2.5. Let me make it a fraction. 1.5. Add 1 to that is going to give me 2.5. And add 1 to that is going to give me 3.5. So clearly, my A is clear. That's A. Right? And then the difference from there to there is 1. And the difference from there to there is 1. Same applies over here. 1 and 1. Okay. Right. So when you get a question like this, do not be alarmed. It doesn't seem straightforward because it's applying both algebra. But really at the end of the day, if you read it, you can see they tell you the sum of 10 terms is 60. Okay, great. Just use the formula for the sum of 10 terms and equate it to 60. Then they tell you the sum of the second and the sixth term, so just come up with a formula to add the second and the sixth and find and equate that to 9. The moment you see you have the same number of variables, or in other words unknowns, with the same number of equations or more equations than unknowns, then that system is solvable, either using what we call elimination or substitution. Good luck.